Yes. Hi, hello students. How are you? I hope you are all safe and fine at home. And already I have given 3 questions, isn't it? I am thinking so you have learned well. So, geography lesson 7 mapping skill I have started, isn't it? So, please students, daily portions you want to study daily. Okay, don't keep it together. So today we can learn about the remaining portion. So once before starting today's lesson, we can recall the previous lesson. Previous class I have given 3 questions. What is a map? What are the components of a map? And one paragraph question also. What do you mean by the term? The scale of the map, explain its classification, isn't it? Yes, I am thinking so. You have write and see also. I have given the homework also, study and write and see in the long size note. Yes, very good. Next, today's portion. Um, Already I learned about map as a tool, maps and cartography, components of a map. Under the heading of components of a map, title, scale, linear or graphical scale, direction, grid system. Up to that we have learned, isn't it? Okay. Now today we can learn about projection. Projection, ligand, conventional signs and symbols, and color codes also. And also 5 question answers I will give. Okay. Now we can see what is the meaning for this projection. Projection means what? A map projection is a way of showing the spherical shaped earth on a flat piece of paper. What do you mean by projection? Projection means a map projection is a way of showing the spherical shaped earth on a flat piece of paper. Okay. See, you can see in the globe also, isn't it? 2 lines are there, latitude and longitudinal lines. Do you know what this line has explained? It has explained about the land masses on it. Okay, in order to show the places, for that only latitude and longitudinal lines are drawn. See, there is one experiment also. Suppose there was a light bulb inside the globe. If you wrapped a piece of paper around the globe and turned on the light bulb, the outlines of the grid and land masses would be projected onto the paper. So, map projection is defined as the transformation of spherical network of latitudes and longitudes on a plane surface. There is one question also. That means name the different methods to represent the earth. Okay, that is one method is map and another one is the projection. So please listen. What do you know about this projection? A map projection is a way of showing the spherical shaped earth on a flat piece of paper. So map projection is defined as the transformation of spherical network of latitudes and longitudes on a plane surface. Okay. Next, projections are drawn to maintain the shape, area and directions. Why these projections are drawn? In order to maintain the shape, area and direction. Okay. Now listen, there are 3 methods of projection. How many methods of projections are there? Say, listen, this line, can you see this grid lines? That is eastern and the northern line, isn't it? So there are 3 methods in widest use as follows. That is the cylinder, cone and plane. So projection on the surface of a cylinder, projection on the surface of a cone, projection directly onto a flat plane called planar or zenithal or azimuthal projection. So what are the methods of projection? There are 3 methods of projection. Projections on the surface of the cylinder. Can you see the first picture? Next one, second one in a conical shape, isn't it? That is the projection on a surface of a cone and projection directly on a flat plane. These are the three methods of projection. Okay. Next one is the ligand. What do you know about this ligand? In some map, you can see at the bottom of the map on the left side or the right side, they may mention it. For what purpose they have mentioned this ligand? In Tamil, we will say Nilavarapadam Kuripu. Okay. Ligand. The ligand of a map helps to understand the map details which are placed at the left or right corner at the bottom of the map. So, where we can see this ligand? Students, listen. The ligand of a map helps to understand the map details which are placed at the left or right corner at the bottom of the map. Next heading is the conventional signs and symbols. Okay, conventional signs and symbols. What do you know about this conventional signs and symbols? These are the standard symbols. Okay, what do you know about this? These are standard symbols used on a map and explained in the ligand to convey a definite meaning. The topography map contains a variety of information about physical and cultural features. So, these conventional signs, these are shown by using signs and symbols in various colors so that the clarity of the map is mentioned. What it was mentioned? The clarity of the map was maintained. So, there are three types of map symbols. Do you know? Students, listen. What are the three types of map symbols? Point symbol, line symbol, area symbols. Okay. Listen. Point symbol. Where we can see these point symbols? Buildings, dipping tanks, trigonometrical beacons. Okay. And the dipping tanks means the tank is full of water. That one. Trigonometrical beacons. That means in Tamil we will say this Mukkona Oli Valikattigal. Okay, in a triangular shape. So the next one is the line symbols. Where we can see this line symbol mostly in railways, roads, power lines, telephone lines. Third one is the area symbols. These symbols are mentioned on cultivated lands, ponds, orchards and vineyards. Okay. And listen, see these. The actual shape of the earth is termed geoid, which is an oblated spheroid. The azimuthal polar projection is depicted on the United Nations flag. North America was prominent on the initial 1945 UN flag, which had the longitudinal line 90 degree west pointing upwards. The following year, the map on the flag was reoriented to be more neutral by having the international data line, that is 180 degree east, lying in the middle of the Pacific Ocean, pointing upwards. The map ended 60 degrees south latitude, meaning Antarctica doesn't appear. Okay. Next, the following color codes are used with map symbol. Already I explained how many colors are there. Brown, light blue, dark blue, green, black, red and pink. Brown color. Where we can see this for all, which places and all in the map this brown color is mentioned. That is land or earth features, contour lines, eroded areas, prominent rock outcrops, sand areas and dunes, secondary or gravel roads. Okay, in these areas only this brown color was indicated. Light blue. What this light blue color was indicated means water features, canals, coastlines, dams, lakes, marshy, swamps and levees, ponds, rivers and water towers. Mostly water area, the light blue color was mentioned. Next, dark blue, where it was used means mostly national waterways. Next, green color, vegetation features, cultivated field, golf course, nature and game reserve boundaries, orchard and vineyard, recreation ground, woodland. Woodland means That is the forest area. Okay. Recreation ground. What do you mean by recreation ground? That is for the enjoyment we are using the ground, isn't it that? So this area green color was used. Next, black color. Why this black color was used means mostly construction features, roads, tracks, railways, buildings, bridges, cemeteries, communication towers, dam walls, excavation and mine dumps, telephone lines, power line, wind pump boundaries, etc. These places only black color was used, and a red color for the construction features, national, arterial and main roads, lighthouse and marine lights. These areas only the red color was used, and pink color for the international boundaries. Okay, so conventional signs and symbols below, the some pictures and some signs are given. You can see that clearly. Okay. So next, some few questions, 5 questions I told, isn't it, that time? This Roman number 4, answer in brief. First question, name the different methods to represent the earth. That is page number 220 and 221. Under the heading page number 220, map as a tool. Under the heading map as a tool, a map is the basic tool of a geographer. It illustrates the Earth's surface clearly and effectively through a combination of drawings, words and symbols. Next, page number 222. Under the heading projection, a map projection is a way of showing the spherical shaped Earth on a flat piece of paper. Up to that, in the same para, 7th line, map projection is defined as the transformation of spherical network of latitudes and longitudes on a plane surface. Okay, student, that is the first question answer. Second question, third question, already I have marked, isn't it? Next, fourth question I will give now. Fourth question, the distance between two cities A and B is 5 kilometers. It is represented by a line of 5 centimeters on the map. Calculate the distance and give the answer in RF. So, representative fraction, already we know the formula RF equal to distance on the map by distance on the ground. So, according to this problem, 5 centimeter by 5 kilometer. So, 1 kilometer equal to 1 lakh centimeter. So, 5 kilometer equal to 5 into 1 lakh centimeter, that is 5 lakh centimeter. So, that is equal to 5 lakh by 5. So, RF equal to 1 is to 1 lakh. That is the answer. Okay. Next, question number, give reason under Roman number 5. Second question you mark now. Okay. Second question, map is the basic tool of a geographer. Okay, give reason under the heading Roman number 5. Second question, first question afterwards I will mark and you. Okay. So for first question, map is the basic tool of a geographer. That page number 220. Page number 220. Under the heading map as a tool, that para full. Okay. A map is the basic tool of a geographer. It illustrates the Earth's surface clearly and effectively through a combination of drawings, words and symbols. These maps form an integral part of teaching geography. A map is a location guide. Okay. Next, third question. Grid reference are essential to find the exact location of places on a map. They don't give reason. That is page number 221. Page number 221. Under the heading grid system, the location of a place can be simply defined by its latitude and longitude. In normal practice, latitude is stated first and then comes the longitude. The latitude and longitude of a place can be expressed in units of degree, minutes and seconds. That's all. That is the Roman number 5, question number 3rd. Next, Roman number 7, answer in paragraph. Second question. Second question, write a note on directions with the relevant diagram. Write a note on directions with the relevant diagram. It is very, very simple and easy question. So, page number 221. Page number 221. So, please students study and write and say this answer. Okay. Direction, under the heading direction, maps are drawn normally with a north orientation. North direction in a map is always towards the north pole of the earth. If you position yourself looking at the north pole, on your right will be the east, your left will be the west, at your back will be the south. These 4 main directions are called the cardinal directions. Direction is usually indicated on a map by a north-south line with the north direction represented by an arrowhead. Okay. So, and below that one picture also has given, isn't it? 8 directions, that picture also you want to write. Okay. That only this answer. This Roman number 7, question number 2 answer. Okay. Okay, students, today I have given 5 question answer, simple question only. So, please study daily portions and write and see also. Okay, thank you, students. Next, survey. What do you know about this survey? Surveying is done to measure the angle, direction, area, height and distance of an object or place on the surface of the earth using instrument. So surveying means what is the measure the angle or direction or area or height and distance of an object or place. That is only the surveying. So surveying techniques are used to obtain the field data and to prepare maps. A knowledge of surveying helps one in map making, particularly in the preparation of physical map. So, what do you know about this survey? Surveying is done to measure, for what purpose surveying is used? It is used to measure the angle or direction or area or height and distance of an object or place on the surface of the earth using instruments. So, surveying techniques are used to obtain the field data and to prepare maps also. So, a knowledge of surveying helps one in map making, particularly in the preparation of physical maps. Okay. Next, geographers mainly use chain for that measurement. What they will use means chain or prismatic compass or plane table, Dumby level, Abney level or clinometer, theodolite total station and GNSS to measure the distance, angle, altitude and position of the area of survey. So, there is one question also. What are the measurement used for this survey? To measure the land. Okay. So, geographers, Roman number 4, question number 5. Roman number 4, question number 5. There one and mention a few surveying instrument. What are the surveying instrument? So, geographers mainly use chain. Sometimes they may use this chain or prismatic compass also to measure the earth or any object or any distance, isn't it? Or plane table or Dumby level and Abney level or clinometer or theodolite or total station and GNSS to measure the distance, angle, altitude and positions of the area of survey. What do you know about GNSS? That is the Global Navigation Satellite System. Okay. So, these are the few instruments used to measure. Okay. That is the surveying instrument. Next one is the, you can see in this picture clearly, modern survey tools used by geographers for map making. Abney level and prismatic compass, this one second, then Dumby level, this one, for long distance and all, they will use this third picture. Next, clinometer. Okay. Next, Gunder's chain. This one is this one was used mostly in the olden days. The early history of surveying in Egypt, surveys are called rope stretchers because they used ropes to measure distance. So the Egyptian rope stretchers. Can you see this picture? This is a rope. With the help of the rope also, they will measure. Next one is the remote sensing as a source of map data. What do you know about this remote sensing? This is also another one question. Roman number 4, question number 6. Define remote sensing. Okay. Remote sensing refers to the observation and measurement of earthly objects without touching them. What do you know about this remote sensing? It refers to the observation and measurement of earthly objects without touching them. Remote means far away. What is the meaning? Remote means far away. Sensing means observing or collecting information. So once again I am explaining. Listen, remote sensing as a source of map data. What do you know about this remote sensing? It refers to the observation and measurement of earthly objects without touching them. Okay, that is the remote sensing. Next one, remote means, what is the meaning for remote? That is far away, and sensing means observing or collecting information. So remote sensing means acquiring information of things or place from a distance using a variety of tools and methods. So there is one question, define remote sensing. This is very, very important. So remote means far away and sensing means observing or collecting information. Remote sensing means acquiring information of things or place from a distance using a variety of tools and methods. Next, see, there is one box. Do you know what are the sensing organs in our body? That we know there are 3 sense organs, isn't it? Eyes, nose, ear. 5 sense organs, but eyes, ears, nose, tongue and the skin, there are 5 sense organs. So 3 remote sense organs in our body. In our body, how many remote sense organs? 3. Eyes. What is the use of these eyes? Sense of sight. Nose, sense of smell. Ear, sense of hearing. Okay. Remote sensing has a long history data back from the use of camera carried by the balloon and pigeon in the 18th and 19th century. But during the 20th century, airborne photographers and satellite remote sensing developed swiftly. During 18th and 19th century, with the help of the balloon or with the help of the pigeons only, we are sending any news or anything to other country or anything, isn't it? But nowadays, in this, during the 20th century, there is an airborne photographer and satellite remote sensing developed swiftly. But now recently in the 21st century, it was fast developed, isn't it? Next one, aerial photography. What do you know about this aerial photography? Aerial photography refers to the technique of obtaining information about places or objects or phenomena with the help of photographs taken using cameras mounted on low-flying birds, balloons, helicopters, aeroplanes and drones. So with the help of all these only, photos also easily taken nowadays. Okay. How this it was taken means by low-flying birds, balloons, helicopters, aeroplanes and drones. With the help of these only, the photography was taken easily nowadays. The aerial photographs are captured continuously with a time gap of 10 to 30 seconds at a fixed height. So each photo will have a slight overlap of area in the preceding photo. By making a mosaic of all the photos excluding the overlapping areas, a stereoscopic 3D image of the study can be produced. If there is an overlap, or with the help of the 3D image, we can all the photo excluding the overlapping areas, a stereoscopic 3D image of the study area can be produced. Next one, Felix Nadar, who was the French photographer. Not only a photographer, but also journalist, novelist and balloonist. So who was Felix Nadar? He was a French photographer, journalist, novelist and balloonist. So in 1858, what he has done means he became the first person to take aerial photographs. So sometimes they may ask one word question, who was the first person to take aerial photograph? That is Felix Nadar. He belonged to which country? French. Okay. So he took his first photograph in 1853. In which year the first photograph he has took? In 1853. And pioneered the use of artificial lighting in photography, working in the catacombs of Paris. Around 1863, Nadar built a huge balloon named Le Giant. Okay, Le Giant. So 6,000, that is the 6,000 meter cube. That balloon was 6,000 meter cube. That is called as the Le Giant. That is the giant. Big size, isn't it? So, next one is the airborne photography. Can you see this picture? There is 60% overlap between photo, forward overlap. So, 20 to 40 overlap between flight lines, lateral overlap. So, aerial photography using drone in the techno world. Next one is the satellite remote sensing. What do you know about this satellite remote sensing? There are different satellite remote sensing. That is the Landsat, Cartosat, Oceanosat, like that. In the lower class you have learned, isn't it? What is the use of this satellite? In order to study some extra things, what is happening in the earth, it is used, isn't it? Satellite, with the help of that only, radio, television, and this phone also, even phone also, we are getting the news at once. Satellite remote sensing is the science of collecting data about an object or area from artificial satellite orbiting the earth. So, satellite remote sensing, what do you know about this? Satellite remote sensing is the science of collecting data about an object or area from artificial satellite orbiting the earth. The term satellite imaginary refers to digitally transmitted images of the satellite. So what do you know about this satellite imaginary? It refers to the digitally transmitted images of the satellite. Next one, this satellite remote sensing. Satellite, what do you know about the satellite remote sensing? Satellite remote sensing is the satellite remote sensing is the science of collecting data about an object or area from artificial satellite orbiting the earth. The term satellite imaginary refers to digitally transmitted images of the satellite. The preliminary data is retrieved from satellite like Landsat, Cartosat, Oceanosat, etc. Fire and flood details can be extracted and delivered to relevant authorities within 2 hours of satellite image capture. Example, major earthquake in China, New Zealand, bushfire in Victoria, and flood in Kerala. Dynamic phenomena such as flood, movement of wild animal, shoreline changes, finding lost ship and planes. Researchers use satellite imaginaries for this. So nowadays, in recent year, in the 21st century, with the help of the satellite, scientists have found out many things. If anything lost or if any changes in the weather condition also, with the help of the satellite, they can find out. Next one is the components of remote sensing. There are 4 components of remote sensing. There is one question also, Roman number 4, question number 7. What are the components of remote sensing? Energy source, transmission path, target, and sensor. What are the components of remote sensing? Energy source, transmission path, target, and sensor. Okay. Next one is the what is the distinguish between, there is one question, distinguish between the aerial photography and satellite imaginaries. So here, satellite remote sensing and aerial photography. Altogether here, 6 points. First one, see, satellite remote sensing. What do you know about this satellite remote sensing? Here, high cost of satellite system takes at least 10 years to plan, construct, test and launch. So satellite remote sensing, it is a high cost of satellite. You want to spend more, okay? And it will take how many years? 10 years to plan, construct, test and launch. Satellite collect large amount of data of the entire area in a short span. Next, it allows global coverage and does not require permission also. Next, satellites circle the Earth. They can repeat and revisit easily. Weather does not affect the functioning of satellite. So, all information in digital, it can be easily integrated with software for image improvement. So, about satellite remote sensing, how it is a high cost of satellite, and how many years it will take means 10 years, and it can collect more data also within a short period, and also it covers the entire global coverage also. And the satellites it will always circle the Earth only, and it can repeat and revisit easily. Here the weather won't affect this satellite. So all information is digital only. It can be easily integrated with the software for image improvement. Next one, aerial photography. What do you know about this? Aerial photography. Here surveying can be planned and executed in a shorter time economically. Okay, so how this surveying can be planned and executed in a shorter time economically? Takes more time to capture an area. How it will be? It will take more time, but at the same time satellite remote sensing, it will take less time. It covers a smaller area and need permission for authorities. At the same time, for satellite remote sensing, it no need any permission, and it will cover a huge area also. Next, revisit or repeatably involve extra cost, but here they are not like that, isn't it? Satellite remote sensing, it will be satellite circle the Earth, they can repeat and revisit easily. But here what we can mean, revisit or repeatably involves extra cost. If it done means we want to spend a lot. Next, adversely affected by the bad weather. But in the satellite remote sensing, it won't affect by any weather conditions. But aerial photography affects the weather conditions. Here it is an analog record, so no further improvement is possible for after obtaining photograph. Okay students, today that's all.